of flight. And marketing, when a Pongal season comes, when another season comes, there will be like people will be buying more of clothes and stuffs and all, right? And when people will buy gold, when people will buy car, when people will buy clothes, so everything is some kind of data driven. So because people have your data, people have your data birth, the companies have your data birth, the company have your buying pattern and all lot of everything, so that this is possible right now. Okay. And it's kind of an different roles are there. So within data science there are like data science, data scientist, a machine learning engineer, data analyst, a business analyst, data engineer, cloud engineer. There are a whole lot of sectors we will see in the later slides, right? And yeah, so before moving on to that, we will see a life cycle of data science, right? So I've been given few questions, maybe 10 or 15 questions. I will try to cover all those questions. I will try to answer all those questions through the slide itself. Maybe later after finishing the session, we will try to focus on the question part alone. We will have a Q&A session to get all your questions answered, right? So when it comes to data cycle, like next is we have 3 more parts left. The one is data science life cycle, the entire process in the data science life cycle. And the next is data science jobs and roles currently available in the market, and what are the skills required for those jobs. So those are the 3 parts. After covering that, we will move on to the Q&A, right? We will focus on the career part. Okay. So when it comes to data science pipeline, as I said already, we have spoken about all those stuffs. Like it's an entire pipeline. It's not that an database or Excel sheet. It's kind of a whole lot of process. But the end goal of any data science project or any kind of data driven approach is come up with an efficient data driven insight, right? So that can be achieved through dashboards or some kind of recommendation engines, or kind of like decision making based on the data stuffs and all, right? So that will be an end product of it. Okay. And yeah, so a data product should help answer the business question. As I said, like the first is the domain expertise and the business question. Like then comes the next approach and stuffs and all, right? But when it comes to data science lifecycle, data science project lifecycle, it is not that software. It's not similar to a software development lifecycle, right? So in software development lifecycle, it goes like this. So what you do, you gather the requirement from the client. Let's say you are going to build an app, like let's say a social media app or some kind of app for your personal use. So first you gather the requirements, then you do the system design. Okay. System design in the sense what are the stack you're going to use, what the database you're going to use, what language your program. Let's say you're for building an app, then it's Android. Let's say you're building an web, then it's mostly HTML and JavaScript, or backend if it is Java or something. So it's more of system design and implementation and testing. The process, the implementation testing goes in hand, it's kind of an iterative process. And next is deployment, and next is maintenance, right? So the process goes like that. Like everything is planned from the business requirements to the maintenance stage, right? Okay. But when it comes to a data science project, right, uh, it's not easy, because in a software you know what to do, what to develop, right? But data science roles are some kind of research roles. It's more of research than a development, right? Because you don't know when you're going to get a result. It's not that you have already have a solution in your pocket and you're just going to implement it and get output out of it. It's not like that, right? So it's kind of you will be having a lot of delivery delays, a lot of hold ups, because at some point you would meet up in a dead end. After that, you would know you would not know what to do or proceed further. You would be taking an entirely different route, right? And non-linear cycles. Yeah, there is no one predefined method or thing to do on do and or achieve something. It's kind of non-linear cycle, and it's highly iterative. You keep on doing the things multiple times, like you kind of revamping or iterating multiple times to come to a solution. But it's not the case in software development, where you have a defined role, right? And cyclical between teams, right? So software development teams, so the initially the requirement gathering and system design is done by architect, even those people are software engineers, and then it's moved on to the developers to build the product, right? But it's not in case of data science, because data science involves software engineering, it involves database, it involves cloud architects, and it involves mathematician, it involves business expert. Let's say if this business expert wouldn't even know to use a computer, but he has everything in his mind, right? But he don't know how to convert into a code or convert into an software based insight or tool or something, right? So it has multiple people are involved. It's like mostly cyclical between teams. Like you are very good at business, but you are not good with programming or not good with the data structure. But what you have to do, you have to juggle the project between the software development team and the business analyst team, and the process goes in like that, right? So this is kind of a data science project. It's not that an predefined rules kind of thing, no, right? So it is very difficult to do the stuffs, and the data science workflow is also not that clean, right? But so like in data science, you will be doing most of Python and R, and you will be doing modeling and prototyping, right? But when it goes to software engineering, you have a language and it directly goes to production, right? But there is one most accepted method, right? That is known as CRISP-DM framework, right? So this is widely accepted framework, or kind of an entire life cycle for a data science project, right? The first thing is, as I said, so understanding the business. Like you should be understanding the business, and next understanding the data, right? Then you have to see whether you can be whether all the questions which you made up during analyzing the business problem can be answered through these data. Like sometime 90% of the data would be like irrelevant for your question itself. It might be like some garbage data or rubbish data. You cannot make use of those data, right? So second thing is like understanding the data and see whether it is suitable data or not, right? Third is data preparation, right? Right. So now Tableau and Power BI, they have connectors to connect to every data sources. You can connect it to MySQL DB, Oracle DB, Hadoop, MySQL, Google Sheets, everywhere you can connect. But previously it's not that case. But again, if you have unstructured data, more clumsy data, again data preparation has to be common, right? That is one part, right? And analysis and modeling, right? Statistical analysis and modeling goes in hand, right? So even for modeling, you should know the histogram, like how the classes are distributed, what is the probability distribution, whether it's a normal distribution or whether it is an like non-linear distribution, where you have to come up with some augmentation technique to balance the data sets. Let's say in one particular case you have like huge number of data, in another case you have very less data, there you'll be going for augmenting database, right? So a whole lot of analysis and modeling. People there are like people like different roles. Those two things are different roles, but 80 to 70 to 80% of the people do both the things, right? It's kind of a single guy doing the statistical analysis and building up the model on its own, right? Again, and the next is validation. So once you kind of build up a model, then comes the validation, whether your modeling is correct or not, whether how it is going to perform in some production environment and stuff and all. Next, presentation and visualization. Either you can put up as a beautiful dashboard for people to see and understand what's happening, or else you can integrate with some software to make decisions, right? Okay, so this is the entire framework for a data science lifecycle project. Okay, and yeah, so and it involves a whole lot of things. So you start you modeling your data in data acquisition. There are like data sources from database and files. We have data pipelines, high streaming, low streaming, environments, and data wrangling. On the modeling part, you have feature engineering, right? Feature engineering in the sense, like let's say you are dealing with some model, like let's say linear regression or support vector machine or whatever it is. All these models are mathematical models. Mathematical model experts input as an numbers, right? You can't feed in an text data, you can't feed in an image data, or you can't feed in an audio, right? So when it comes to modeling, the first and foremost thing is feature engineering. Now recent days I got to realize that feature engineering is kind of a separate role, right? To properly reformat the data so that an modeling developer can actually make use of those data, right? Feature engineering is kind of an hot area. Like it's a lot of skills are in demand in that particular area. So once your features are proper, then modeling is damn easy, right? You have all whole lot of algorithms already available. You're not going to reinvent or not going to create an algorithm of your own, right? From early ages, like as I seen, the naive Bayes algorithm is actually discovered in 1700s, right? Like it's like 300 years ago. And whatever the model linear regression, Markov chains, or any Bayesian algorithms or stuff, it's been already developed. So the critical part is in the feature engineering, right? And next is model evaluation. You will be doing cross validation stuffs and all, right? So this is kind of a two area. Like one is modeling and data acquisition and understanding, and third comes the deployment, right? Once goes to deployment, it will either turn up as a dashboard or as a service or as a decision making tool kind of thing, and it goes to the customer, right? Okay, yeah, and again this is the same, like ask question, get the data, explore the data, model the data, and then communicate or visualize. That is the entire pipeline, right? and yeah, whole lot of things, the same things are repeated again and again. But when you are getting data can be from different sources. It can be logs from a web server with mostly and textual data, social media data, let be Twitter data. So based on the Twitter data, you can find which party is going to win. It's actually true. Like using the Twitter tweets or using the Twitter polling, you can actually find it out. Most probably, you can predict up to like 60, 70 to 80% of accurately. You can predict which party is going to buy or which movie is going to become hit and stuff and all, right? And you have census data, and you have a whole lot of online video APIs in YouTube and web scraping and stuff and all, right? And data can be from any different sources, like whole lot of sources are there, website, table, APIs, and database and stuff and all. And these are the process involved. Like when it comes to data store, you have CRM, you have ERP systems, you have Excel sheets, and the types will be images, audio, text, and data, IoT data, satellite data, telecommunication data, and social media data, right? And data acquisition part, mostly Spark and some kind of data infrastructure to collect those data and analyze those things. And data storage, Hadoop file system or a regular database or Google Sheet or whatever it is you will be having. And BI and analytics, their Hive and Spark is there, but BI and analytics, when it comes to more of MBA perspective, you can use Vika or Power BI or Tableau or some kind of Plotty or some kind of tool which is ready-made, right? So this Hive Spark, so Spark is a streaming platform, and Spark has a plugin or its own called Spark ML, right? So using Spark ML, you can do real-time analytics. Like you don't have to store the data, then retrieve the data and process. As the data coming in, you can do real-time stream analytics. It's kind of one area, right? Spark analytics. Then report and visualization. You can plot graphs and Tableau and stuff and all, right? Okay. And mostly it's unstructured data, right? Unstructured data cleaning checklist to update a data, to fill out missing values, to remove duplicate values, to find out numerical outliers, to check IDs, and to define validate outputs. So all these data cleaning checklist are doing or done using during the process of feature engineering or some kind of statistical analysis, right? So when you apply all those analysis on the data, you would know what's the problem with data. So only after fixing the data, right, you go on to the modeling process, because 70 to 80% of the effort is actually put up in the data cleaning process alone, right? Yeah. So these are some of the tools. So once after cleaning your data, right, after cleaning your data, then you go for hypothesis and modeling. So then comes in the tools like Python. In Python, we have libraries like scikit-learn, pandas, NumPy, and a whole lot of tools for machine learning and deep learning stuffs and all. And R is more convenient for you people, I think, right? Because Python is more of a general purpose programming language. So R is kind of dedicated to the data science problems alone, right? And MATLAB is more of dealing with matrix data and stuff and all. Okay. And next you have Perl. So you have a whole lot of languages. And when it comes to modeling, you have a bunch of algorithms. So it's not it's mostly machine learning algorithms I just compiled up. I'm not that aware of the business problems and business algorithm stuff and all, but it will be mostly applicable for your use case as well. So we have supervised, unsupervised reinforcement. For classification regression, you have linear regression, decision trees, KNNs. I think decision trees, SVM, naive Bayes, these things are mostly used, like KNN, a priori, XGBoost. So these are all most used algorithms, right? And next comes the evaluation. So the first process is data collecting, data cleaning, and the second process more of modeling and hypothesis, and the third process is kind of evaluation and interpretation, right? There you can apply upon some kind of technique like cross validation, confusion matrix, and you can use up some metrics to evaluate your model, how it is performing, like whether it is sorry for the disturbance, whether it is performing as expected or it is not, right? And again, it's confusion matrix stuffs and all. Okay. And there are a few problems like overfitting and underfitting. It's like kind of an out of the scope. Like we'll just move on to the next thing. And next comes the deployment stage. So deployment stage is mostly done by a software engineer. It's where more or less of business analyst and stuffs and all. Okay. And after deployment, it's continuous monitoring. So see, you have built up a model based on the previous data or history data, so you will be getting a lot more data in the future, right? So there is one area called active learning, so where you get real-time data and you just validate whether your predictions are correct or not, and you try to improve your model on the go, right? The process goes on like that, right? It's an entire pipeline. Okay. And yeah, so with that we will move on to the framework part is over. So we will move on to the data science roles and skill sets, right? So after that, I will just address all those questions which has been asked. Okay. So data science role, there are a whole lot of roles available, right? So right from data scientist, data science itself a broader area, data scientist, business analyst, okay, data analyst, machine learning engineer, deep learning engineer, computer vision engineer, okay, data analyst manager. So there are a whole lot of domains involved. Like we will see every roles, what their roles are, right? What they're going to do and stuff. Okay. Yeah. So the first thing, we have business analyst, right? So this business analyst is kind of an management role come analyst role, right? So they are like more focused on the management part and a little bit of analyst part, right? So they will be like planning the business problem, and they will be kind of interacting with the client or acquiring some use cases, right? And it's more of kind of managerial role combined with some kind of data analyst role, right? So they will be mostly defining the goals and what to do and what to do. They will not be dealing with more of data, right? It's more of the more of focus is on the business problem, like that is where business analyst comes in, right? So next is data analyst. Data analyst, like mostly you will be dealing with the data, right? Its most entire job is on data and dealing with data, and less of a business problem, right? So that is one business analyst role, like where he is responsible for like very top level managerial role, and he makes the decision and plans the strategy and stuff and all, right? So he'll be working on with some kind of PowerPoint and SQLs, Google Analytics, Tableau. It's kind of very high level. You'll be just creating graphs and see what is happening and what is going around the things, right? And the next comes the algorithm engineer. So his primary role is to you have a data, like you'll be doing less of data cleaning jobs, right? You will, even though you will be doing, but his job is to come up with a proper model for the proper business use case, right? So let's say it's a prediction problem or a classification problem or a computer vision problem or whatever it is. So you'll be coming up with the proper algorithms and stuff. Okay. Next is data science scientist. So data science is kind of a multidisciplinary role. It requires different thing, right? Uh, like coming from the mathematical background, you can acquire some kind of computer science skills to fit in this role. And when coming from the computer science background, you can borrow some skills from mathematical and statistical professions, and you can kind of merge it. It's kind of an intermediate role. You can see data science is a combination of computer science, mathematics, and domain and business knowledge. But the first thing is domain knowledge and mathematics, and again you can acquire computer science. But all three are equally important. It's not that you can leave one thing. So anyway, even if you're starting as an mathematic or statistician, later down the line on 6 months or 1 year, you will be you will be learning at least some kind of computer science techniques, right? But when it comes to machine learning, it's more of computer science and mathematics. There is no business involved, a lot of things, right? And again, business and computer science, you will be seeing software development, right? And when it comes to mathematics and business, you will be seeing traditional research, like the basically business analyst based research and stuff. Okay. And data analyst, as I said, you will be dealing mostly with data, coming up with beautiful visualization, deriving some insights from data, and kind of giving valuable insights what is happening and stuff and all, right? He will be also doing some kind of data cleaning, and even he also do some kind of data modeling and stuff and all. Okay. And ML engineer. So ML engineer is kind of similar to an uh, data analyst, or some kind of similar algorithm engineer, right? But ML engineer will also focus on productionizing the thing, right? Productionizing this thing is ML engineer is it's a combination of data scientist plus software engineer, right? Or it's a data analyst or an algorithm engineer plus software engineer. So he will focus more equally on the data part, on the modeling part, as well as the production part, how to deploy it, how to service as a web, how to put into a mobile app, right? Let's say you have a whole lot of onboard ML capabilities in your mobile phones, in your laptops and cameras and stuff and all. So you will be focusing more on productionizing things. So you'll be taking care of the software engineering as well, along with the data part, right? And research scientists. And again, you can take up a PhD in some kind of elite institutions, and you can go on discovering or creating new algorithms and stuff. Okay. To solve a different problem. Still, there are a lot of business problems or a lot of places where it's yet to be explored. Data is there, right? Data is already there, but the models which we have will not be able to accommodate like 70 to 80% of the data. The modeling can be done, right? But even we have some kind of different sparse data, or else you can come up with a new strategy or new technique to improve the performance, or to reduce the training time, or to reduce the cost, right? Every system can be improved. It's not that everything is already done. A lot of things have been already done, and yet you can research and come up with new algorithms and stuff and all, right? So research in the stuff, it's not people thinking research means finding out or discovering or inventing a new thing. It's not like that, right? You have to improve a system. Let's say even you take a decision tree model, right? So based upon the decision tree model only random forest is there, right? The random forest, there is initially there is only bagging concept where you aggregate thing. Now it is boosting concept is there, right? So you take up a model and you can see how to improve the model to increase the accuracy or to increase the or to reduce the time, right? It's an incremental improvement for a model or a technique. So that is where research comes in. You will be focusing more on the algorithmic part rather than solving a business problem, right? Okay, so that is where research scientist comes in. So these are some of the roles: data scientist, data architect. Data architect will focus on more of database, Hadoop and stuff and all. Okay, and data engineer, you will be dealing with cleaning up the data and stuff and all. And statistician, he will coming up with new strategies to helping. So I have known like in a data science team within a company, let's say TCS or Infosys or whatever it is, right? You'll be having a data science team with different people, like one mathematical researcher, like you will be like you would have been done a PhD in mathematics, right? And there will be few computer science background, like 4 or 5 software engineers will be there, and 1 or 2 business experts will be there, right? So this team is not one person can't do everything. It's a combination of different people put up as a team, right? So this mathematician will focus on, like you will be reading some research papers. Let's say if a software engineer is not able to understand some formulas or understand some newest models, what he will try to do is he will try to simplify it and try to help a software engineer to actually write code on it, right? And when a mathematician gets into a problem, this software engineer will support him. It's kind of a collaborative effort to make a data science project happen, right? Okay, and you can fit into any roles. Even you can do multiple things on you can try to juggle between different technologies, or else you can become an expert on one domain, and you can try to fit in those kind of roles, right? And again, data science skills, right? When it comes to data science skills, we have whole lot of things, like it's right starting from, so AI when it comes to broader category, it's not software engineering, it's not modeling. It involves human neural science, it involves brain anatomy, it involves psychology, right? It involves ethics, morals, and it's very broad area, right? We will focus on the data science part alone. Like even in data science, we have visualization, statistics, machine learning, deep learning, database, and neurocomputing, AI, a whole lot of things, right? But as a decent data scientist, these are the skills you must be having, like statistics, very good in statistics, right? And at least one or two programming languages like R or Python would be comfortable for you, I think, right? And again, data extraction, transformation, and loading techniques, mostly pandas is the Python library which will be handy doing all those tasks, right? And data wrangling and exploration, okay, EDA and stuff and all. Machine learning algorithms, there are like top 5 or 10 algorithm available, which is mostly used. You can learn and implement all those algorithms. And advanced machine learning. So deep learning will not be that suitable for you people, because you will be trying to address some kind of business problem. But when you want to get into computer vision, or when you want to get into robotics or natural language processing, then you will be working with deep learning stuff. And big data processing frameworks like Hadoop or Spark or whatever it is, the pipeline, right? So you need a data to consume, right? And data visualization to plot a graph or pie chart or donut chart or whatever it is, right? Okay. And what it takes to become a data scientist, again I said, as statistics and library, good solid grasp in library, pandas or scikit-learn stuffs and all. And you should be known the process, how to data wrangling stuffs and process, and this is data collecting process and data wrangling process, okay? And EDA, exploratory data analysis, okay? Visualize things in hyperdimension and see how it is going to working. And training, model building and stuffs and all, okay? And yeah, and again, dealing with data stuff and all. For dealing with data, we have infrastructure and stuff and all. So these are all more of software things, right? Okay. And yeah, so these are all the things you will be like doing. Like I think hope you have got some kind of understanding on what is what things, okay? And we have some kind of interesting questions being asked, right? We will focus on the data. So through this data, I will answer some of the leftovers which I forgot to tell in the slides pass and all, right? Okay. But when it comes to summary, right?